Good day, everyone. I am Evangelia Papadopoulos. I am the engineering manager for power plant simulations at L3HARRIS, located at our Canadian office in Montreal. Today, I'd like to share with you some information on a large-scale software modernization project of a legacy nuclear power plant simulator that we recently completed. The topics I'd like to cover will include an introduction to the reference plant, some background of the simulator, an overview of the scope of the modernization project. Then I'll talk about the modernization of the plant systems, the simulator platform, and the validation results. Then I will continue with the discussion on the project schedule and some conclusions. So let's start with the introduction. So the St. Lucie nuclear power plant is operated by Florida Power and Light, or FPL, which I will use as an acronym throughout my presentation. It is located, as you can see on the map, on the left-hand side between Miami and Orlando, but more specifically on Hutchinson Island between Fort Pierce and Stewart. It is a combustion engineering two-loop pressurized water reactor, including 2 steam generators and 4 reactor coolant pumps. It consists of 2 units. The units began commercial operation in 1976 for Unit 1 and 1983 for Unit 2. They have recently received a license extension until 2036 for Unit 1 and 2043 for Unit 2. Now let's have a look at the operator training simulator and its timeline. The training simulator was originally delivered by L3HARRIS, which was then part of CAE in the mid-1980s. So as you can see in the figure below, there have been many updates implemented on the simulator throughout the years. Some of these updates include modifications by third parties. This resulted in a simulator that became difficult to maintain. The plant models, which were primarily Fortran-based, so non-graphical, made it difficult to implement plant modifications on the simulator. Also, with an aging simulator maintenance team, with the plant extension into 2043 for Unit 2. Unit 2 is the reference unit for the simulator. It was of paramount importance to modernize this simulator. The contract was then awarded to L3HARRIS in late 2019 to perform this major software modernization. So what was the purpose of modernizing the simulator at St. Lucie? The main goals were really to modernize the simulator user interface as well as the models. This would then simplify the simulator maintenance, facilitate the implementation of plant modifications on the simulator, and would even increase the pool of candidates that can join the simulator team. With the aging workforce, the new generation of incoming workers, using those legacy Fortran models on a 1980s simulator well into 2043 was simply not going to cut it. The customer also saw some additional benefits to modernizing the simulator, such as the increased model fidelity. Since the models have improved over the years, this would then improve the quality of the training and therefore enhance the operator skills. Now let's talk about the scope of the simulator modernization project. It consists of a full replacement of all of the Fortran modules, the non-graphical models, using our homegrown ORCID modeling environment, which has an object-oriented design simulation environment and is based on first engineering principles using the drag and drop methodology. So the update would include all the simulator systems, including the containment, the primary auxiliaries, the radiation monitoring, all of the balance of plant systems, as well as the electrical and instrumentation and control systems. It would also include the latest ORCID software environment, as well including the ORCID Instructor Station touch version. The data management system would also be deployed. So we were using the SharePoint data management system linked to the ORCID modeling environment. So when each modeler would develop their systems, they would make reference to the documents that were used within their ORCID model, which was developed. As well, the virtual panels have been upgraded. Overall, the entire modernization project would result in a seamless integration of modern, accurate plant system models, all controlled with a Windows 10 type interface. Now let's look at the simulator modernization itself. The model improvements essentially was meant to replace all of the legacy Fortran modules with graphical models using our ORCID modeling environment. So 44 plant systems had to be replaced and had to be modeled within ORCID-ME, our modeling environment. So what you see here on the figure on the left is Fortran modules and their equivalent replacement on the right, the graphical representation. Some of the key model improvements and benefits of this modernization project are the higher fidelity models, the upgraded system stability during transients, the detailed simulation of the electrical distribution down to the instruments and the control power supplies of the relay control. I also mentioned that the platform was upgraded. So we upgraded to the latest ORCID simulation platform, which included the ORCID Simulator Executive and the ORCID Instructor Station. The Simulator Executive offers graphical representation of all of the simulation modules, and the modules can be dragged into different time bands and also allows for real-time, fast time, and slow time execution. The ORCID Instructor Station has been upgraded to a touch version and can be used for desktops and tablets, the same version of the Instructor Station for both desktop and tablets, which uses Windows 10 iPad-like functionality such as swiping, flicking, and pinching, and is designed for the next generation of instructors and maintainers. We also upgraded the virtual panels. The virtual panels are essentially a software replica of the main control room. Here we're also using an object-oriented approach. So we have panel object libraries available within our ORCID graphic editor. So similar to the ORCID modeling environment. So we have our latest object libraries available, which include recorders, controllers, and so on. Another neat feature is that we have computerized systems or HMIs embedded within the virtual panels. This is what you see here on the top right-hand corner of the figure, exactly as it would be within the main control room. The virtual panels have been created using a one-world view, meaning that the control room is continuous and not in discrete panels. Also, pan, tilt, and zoom are capabilities which are supported within the tool. We have also improved the look and feel of the active schematics. These active schematics are just simplified diagrams that the instructors make use of within the instructor station. So if, for example, when they want to insert some instructor actions, such as malfunctions and remote functions, they can do so via these simplified flow diagrams. So here we can see the highly integrated environment within the instructor station. So we have access to the active schematics, those simplified flow diagrams, the actual model schematics, and the virtual panels. We also have the capability of browsing from one to the next just by right-clicking on the object in question. Also, the instructor actions are available here as well. So within the active schematics, within the virtual panels, or from the model schematics. We validated the simulator by comparing the results with the actual plant events. So what we have here is an example of a reactor trip with the plant data available in blue and with the simulator data that is shown in red. So as you can see in both these plots, given the values and the ranges, we are well within the ANSI standard tolerances. Now regarding project schedule and key challenges. The project was almost entirely run during the pandemic. It started at the end of 2019. We had the design review meeting remotely in April of 2020. The software development was completed in the fall of 2020. We then began acceptance testing with our pre-factory acceptance test period, which started in March of 2021. This was then followed by the factory acceptance testing phase, which was completed in August of 2021. Both of these acceptance phases were completed by running tests on 2 independent sites. Finally, the site acceptance testing was recently completed on site in Florida. The major challenge on this project was really overcoming the COVID-19 limitations, essentially running the project during the pandemic and ensuring that we met all of the project milestones, that we stayed on budget and on schedule. So we had all our staff working from home. Most of the work was completed working from home, such as the development, the integration, and the testing phases of the project. How did we do this? And frequent communications with the internal project team, as well as with the customer team, were paramount. So by using acceptable communication platforms such as Teams and Skype. Due to the travel restrictions, the acceptance testing phases were completed with testing done on both sites in Montreal and in Florida. Each site had its own set of dedicated tests, and the customer in Florida used their previous classroom or glass-top simulator to run the acceptance test procedures. On our end, the acceptance test procedures were run as automated scenarios. The latest simulation software was installed using remote access. Configurations were provided using our secure file exchange. And of course, where possible, we compared the results of the simulator against the plant data. Finally, the site acceptance testing was conducted on site in Florida with L3HARRIS support. What are the conclusions? To conclude, we were quite successful in completing this project during the pandemic. Our customer, St. Lucie and FPL, now have a next generation full scope operator training simulator. This simplifies the maintenance on the simulator for years to come. With the upgraded user interface, the customer will be able to implement upcoming plant modifications on the simulator by themselves should they wish to do so. This ORCID software and this state-of-the-art simulator facilitates the onboarding of any new simulator team members. That wraps it up. I hope you gained some value of the information I shared with you today. Thank you.